Hello everyone, this is Shambhavi and I'm super excited to share my 5 lessons that I learned from launching machine learning products. And I'll first set some context by sharing the ML products that I worked on, followed by the lessons, and then I'll leave you with a framework that you can use to prioritize and build ML products. So let's get started. So first, a little bit about me and my product journey. I actually started as a software engineer, like a lot of product people. But fairly quickly, I pivoted to product after graduating from CMU. And so I held product roles at various companies, starting with Sears Holdings, Home Depot, Groupon, and Amazon. Currently, I started my startup called Mentor Me Good to help people land their dream jobs in tech, including product management and other roles. So if you're curious, check out mentormegood.com. Now getting into the ML product, I wanted to make my talk more accessible to everyone. So I picked out 3 ML areas and corresponding examples that I will be using throughout the presentation to communicate the lessons. The first one is recommender systems. The specific example that you see on the screen is a product recommendation widget on the product details page that shows the products that the customers eventually ended up purchasing when they viewed this product. Recommender systems can have different underlying ML algorithms. The one that I had experience with was called collaborative filtering, which is based on this idea of identifying similar users based on a common action like a view or a purchase. The next one comes under the umbrella of conversational AI. And so the use cases include, or the use case is where you want to interpret a written or a verbal language. So for example, chatbots, virtual assistants, and usually the stream of machine learning algorithms that comes into picture here are natural language processing. And my specific experiences with like Alexa, where I worked on improving the goal completion rate of Alexa, which in simple words measures the percentage of time Alexa does what it is supposed to do correctly. So we'll use this example as well. And then the last one that I picked is about product classification. Now, classification is a very popular ML technique, if not the most popular. And so the use cases or examples range from identifying whether the email is a spam or not, identifying fraudulent transactions, and also like counterfeit products. And I worked in Amazon business, which caters to B2B customers. And I launch features where I use machine learning to make sure that the B2B customers are not buying things or not seeing even things in their buying experience that doesn't comply with their procurement policy. So with this context, let's move to the lessons, but I want to share a quick note on the why of this, why I'm sharing the lessons. So there are 3 reasons to help product management or product managers to prioritize more ML initiatives that have high chances of success, and how to do that. Then identify the use cases where ML is not the best solution or not the only solution that you can go for, and then how to look for alternate solutions. And lastly, helping disambiguating the cost and the returns early on, as soon as possible, in a structured way. So that brings me to the first lesson, which is define the success criteria of your feature or product, independent of whether the solution will be powered by ML or not. If you define the success criteria, assuming that ML is going to solve the problem, 2 things will happen. First, you'll miss out on the alternate solutions that may be more cost effective or even give you higher performance certain times. And the second thing is you'll miss on the metrics that captures how well your solution or feature is from a customer's lens. And because you'll tend to define metrics that will measure the models as opposed to how effectively the benefit is being translated to the customers. So let me give you an example. So let's say that you are a PM for a big e-commerce company with millions of users, and you have identified that there is a problem of counterfeit products. So you as a PM come in, and then you have a hypothesis that if we bring down counterfeit products, then it will result in more number of orders because there will be more trust in the platform. So with this hypothesis, you move forward and you try to define the success criteria. So, and in this case, you're assuming that the solution will be powered by machine learning. So the first metric that you will have in your success criteria would be directly from your hypothesis, because you said you'll be increasing the orders. So you'll have something like increase orders by X%. Now, when you try to measure the quality of your solution, assuming that machine learning is going to solve, you will probably come up with something like this, which is to measure the precision, recall, and accuracy of the model itself. Now, for a minute, think about the same use case, but you try to define the metrics keeping in mind the customer and like from the customer lens, what would change from the customer experience perspective. So probably you will think about, okay, today they are buying X number of counterfeit products, tomorrow it should reduce if my solution is effective. So you'll have things like percentage of counterfeit products purchased every month, percentage of counterfeit products viewed out of the total views, the number of tickets related to counterfeit products, and of course you'll have those accuracy metrics of your overall solution. So that's one thing, but it's very important because once you define your success criteria like this, you will not just be limited to machine learning. Your overall solution can comprise of machine learning, even like manual classification, heuristic classification, which I'll get in a little bit. So moving to the next lesson, which is to get evidence on business impact early on. There's this perception that machine learning is like this, like a magical fairy dust that could solve everything, and which is not true. So you should definitely get the business impact like any other feature. And why? To be more confident on your ML investment, potential ML investment, and to get those like buy-ins from your leadership and trust, establish the credibility. So you may answer, okay, fine, we'll do that. But how do I do that? Because I don't even have a model to spit out the right output. How am I even going to estimate the impact? So there are ways. So for example, we looked at product recommendations, right? Now, if you want to see the business impact, you could create an experience that is powered by a static or a curated list to have a reasonable measure of the benefit. You could measure the engagement on the widget, the eventual conversions, and this way you won't fly blind. You will have some sort of like directional idea on what the business benefit could be. So coming to lesson number 3 now, which is to, before jumping into a full-fledged machine learning solution, give heuristics a chance, evaluate all the heuristic options. Now, what are heuristics? So heuristics are these simple rules that are based on the past experiences, and typically they are cheap, like you can create it quickly, they are fast, and so for example, let's say you want to design a system where you have to detect fraudulent transactions, and you don't have anything in place today. So you could think about these creative rules where there are chances that you will be detecting a good amount of fraudulent transactions. So for example, are there high value transactions in the last 30 to 60 minutes? Is the transaction coming from a zip code which is totally new? If these are the cases, and if they satisfy this if then else type of rules, you can mark the transaction for hold and send a notification out to the customer to confirm if they are indeed their transactions. Now, this sounds very frivolous, simple, but if you compare with your current situation, if you don't have anything, it's better to have something that works in the interest of the customers. So let's have a deeper look into the benefits of using these heuristic solutions. The first one is, as I said, the cost. You can do it faster compared to the ML solution, and you may get a higher performance as well in some use cases. The second is time to market advantage. Now, so this depends on your unique use case and how the competitors are solving a problem, and legal, and there could be various other reasons where you want to get the time to market advantage. So if it works for you, you will get that. The third one, I think, which is like a really useful one, which is that you want to eventually do a machine learning solution, but you should have a frame of reference of the cost and performance using the heuristic solution, because you may use it to create training data, or you should have that comparison to measure the return on investment, because the cost for heuristic is going to be lower than machine learning. The last one is about enabling your business to have hard constraints. Now, there could be use cases where business wants to have hard constraints. And with machine learning, you cannot really reverse engineer from an output to really understand why a model predicted an output that it did. So if you want to have a hard business constraints, you will have to use some kind of rules in combination of machine learning or not. So this concludes my lesson 3. Going to lesson 4, which is about understanding and communicating the cost of using machine learning for your use case. So why is this important? Well, you have to estimate the return on investment like any other feature. When you want to put it in the roadmap, you need to really understand the business impact as well as the cost to figure out the returns. And lastly, you want to build trust. Especially if you are going to pitch for the first machine learning project or product in your team, you need to get that credibility and like sign off from your leadership and stakeholders. Nobody likes when the funding for their projects get pulled, so that's really important. So let's look at like, what do I mean by the cost, right? So when you talk about traditional type of features and products, you look at the dev cost. So you will do some sort of like t-shirt sizing, working with your engineers. They will tell you the time, effort in terms of weeks during your sprint planning. But in case of machine learning, you have 2 additional types of cost. So one is the infrastructure cost. It will depend on how intensive your model is. So like what kind of resources and data it is going to use. Are you going to run it like in a real time, or you want to run it and store the output and then like use it later? So it'll depend on a number of factors, but you should ask those kind of questions to figure out like what is the cost of the infrastructure. The second part is the cost of training data. Now, for most of the machine learning algorithms, the model will require a golden or a labeled data, which would be a set of input and the correct output, which the model needs to understand the pattern, so that when a fresh input data comes in, it can predict correctly. So it is important to know what the cost of this training data is. Now, to understand the cost, first you need to understand what is the training data in my use case and how do I get it. So going back to the 3 examples that I mentioned earlier, you have a product recommendation widget, you have counterfeit products, and Alexa. Let's look at the training data for each case. So for the first one, there would be 3 elements, as I said, like with the collaborative filtering, you want to figure out most similar users based on a common action. Let's say that is purchase here, so you will need the data on the user, the product, and the purchase flag, like whether they purchased it or not. Now, how do I get it? So in this case, when the user makes a purchase, does the checkout, this data is generated automatically, right? So you don't have to do anything. Yes, like you have to pull the data maybe from a different table, integrate it, do all that stuff, but you don't have to create the data. But let's consider the counterfeit product. Now, if you remember, the model will need a set of input and the output, which are correct. So you'll have to have a list of products and then whether they are counterfeit or not counterfeit. Like a business who is listing on the website, like a company, or even if you are selling directly from the manufacturer, a lot of times, like, you don't have that information. If something got switched during the supply chain, you won't know all those information. So, and this information is not automatically generated. So the only way to have this is to have some kind of like a team, or source it to a third party where humans will actually provide that information. They will look at the product, different attributes, manufacturer, rating, the reviews, even the subjective information on the reviews. If a product has been having a lot of reviews that, okay, this is a counterfeit, those things will give a signal to tell whether something is counterfeit or not. So you'll have to have humans. Now, coming to the last example, which is about a virtual assistant. It could be any virtual assistant, not necessarily Alexa. But if you are, if you want your model to really learn what the user has said, understand, interpret, and respond back, you have to do two things. Like, first, you have to transcribe your the dialogue so that a model can read it, and you also have to divide it into different parts, the whole dialogue, to make sense out of it, assign meaning to it. For example, if I tell Alexa to play Hello song from Adele, it needs to know, okay, Adele is a music artist, Hello is a song, and so someone needs to annotate all this data. So again, in this case, there would be humans, and in fact, for a lot of these virtual assistant products, there are teams like 1,000, 10,000 people who are just kind of transcribing, annotating, so that the model can learn the evolving things, right? Like previously, probably Alexa or Google didn't know about coronavirus, but when it came, it has to learn it. So this training data has to be constantly refreshed, retrained. So when you now know what the training data is and how do I get it, you will be able to know or figure out what the cost would be. So in a very a simple way, you will see how much time it takes for one human to do training data for one unit of item, be it product or dialogue, and you can just estimate from that. Now I'm coming to the last lesson, which is that do not make 0 to 1 prioritization with ML, right? If you're doing a traditional product, let's say on an onboarding form, you want to have a feature to validate email address, it's a 0 to 1 prioritization. Like, you'll create a user story, you'll work with the engineering, you'll get it prioritized, you'll fix it. But when you want to use machine learning, it's a bit of a different game. And I'll walk you through sort of a flow where you ask yourself these different questions to understand whether or not you should prioritize the machine learning or not. So the first question is does heuristic solution alone meets your success criteria? So remember, first you have to define the success criteria. You have to explore the alternate heuristic approaches. And if you do that, you'll know whether heuristics is meeting your success criteria or not. If the answer is yes, you ask yourself if this heuristic method is going to scale for the next 3 years based on your growth projection. If the answer is yes, then you prioritize the heuristic solution and then revisit later, because you can use your resources and time for other stuff in your company. Then if the heuristic approach is not scalable, you ask yourself another question, whether the time to market advantage that I'll get with heuristic approach, is it worth it? And if the answer is yes, again, you go for heuristics. If not, you look at the business benefit and the cost of using machine learning, which we just talked about on how to estimate that. So if it is a good investment, you prioritize the machine learning model. But again, even at this stage, you do not know if this is the right way, because you will just, you have just prioritized the model exploration. You don't know how well it will be, whether it will meet your success criteria or not. But you do that, you explore, and if you find out that your machine learning model is going to meet your success criteria or meet it in the future with more investment or like more experimentation, if your data science team is confident about it, then you prioritize it. And if the answer is no, then it means that you tried everything and you're still not able to figure out a way to solve the customer problem because it doesn't meet the success criteria. Then maybe you should think about other things that you can work on, other customer frustrations that you can work on. So now this brings me to the last part of my talk, which is the final takeaway, a framework that is inspired by these lessons that you can use to think about prioritization of ML products. The first step is defining the success criteria. So do this upfront and do this without assuming that ML will be the solution. Step 2, get evidence on business impact. So like any other feature, do experimentation. You don't have the model, you can use curated, like manually curated, static kind of output. The third one is evaluate the heuristic approaches. You should be clear as a product manager on why the heuristic approach will or will not work in your use case. And then the step number 5 is to understand and communicate the cost of using machine learning. So look at the infrastructure cost, look at the cost of training data. And the last step is the phased prioritization. So do not make that 0 to 1 decision. Think about different factors like will heuristic scale for your business? Is the time to market, how important is time to market? Is your short-term and long-term solution same? And yeah, so with that, I think I'll just open it up for the questions.
Yes, thank you very much, Shambhavi. Can I ask the first question from a PM perspective? And that is, how much do I need to understand about the model? I've worked with data scientists before, and what they explain is the model extremely complicated in their own world, but me as a product manager, I need to go through these steps. At the end of the day, what I want to have is a quick analysis of is it that's going to pay off? Is it worth it?
Yeah.
And I noticed there is a bit of a language problem.
Yeah, absolutely. So that's a great question. I think as a product manager, like you don't have to create the model or retrain the model or anything like that. But as a product manager, like first you are the advocate of the customer. So you need to understand what are the levers, different levers in your model and how you have to work with your data science team to fine tune them so that the customer problem is met. For example, if I'll take an example of something that I shared here, right? Like the counterfeit products. So what is the tolerance of customers of that counterfeit products? Like, and based on that, you can define and align on the goal for with your data science team. So let's say you have you're using combination of both heuristics and machine learning, and overall you want to make sure that like the model is X% precision. It has X% precision, which means that for all the products that are there, 80% of the time the model correctly identifies that this is a counterfeit. And the second thing is you have to align on the recall metric, which is that it captures like 80% of the counterfeit products, for example. And beyond that, you really don't have to go into how the model actually works. In fact, today there are a lot of libraries, so even the data scientists have a lot of things in their toolkit and they don't have to create things from scratch. So you do need to, as I said, like understand the levers and how they tie back to the customer experience. And yeah, align on that metric and have everybody in your team align on that.
Thank you. Do we have other questions? Yes, we have one. There was someone else first.
Hi, here. Okay. Azam from Delivery Hero. So a question about using ML for preventing fraud. So one of the problems in fraud prevention is understanding if the customer has multiple accounts. So in the machine learning training model, you have to provide a lot of information, but how much a lot are we talking? So we can provide the IP address, any device information, and so on. But is there a best practice to understand for how deeply do we go in providing information to the ML model?
Yeah, so for this case or for any other case, as a PM, you will have some kind of hypothesis around what are the different attributes, or which is called features in the ML world, like what features should we use in the model, right? And you will transfer your like hypothesis to the data scientist, who will then work on like various versions of the model. Maybe in model A, they will only be using like the accounts information, not like just a couple of attributes. And in another model, they'll use more, and then there'll be an experiment to see which model performs better, which model is able to capture the fraudulent transaction in the most effective way, like those precision and recall and accuracy metrics. And hence, there is a lot of a duration in this experimentation itself. Like once the model is ready, it's basically then the job of the dev team to read it and like give it to whoever team that they have to give it to, or render it or use it however. But there is this long timeline where you're going to use combinations of like these attributes to see which is better, because the answer is like nobody really knows upfront, and that's the reason nobody is able to really reverse engineer on why one model worked versus the other. So it's a matter of experimentation.
All right.
But I would say that you go with maximum attributes, and then you narrow it down to see which is working better.
We have time for one last question. Yeah, please.
So thanks a lot for the talk. It was super interesting. In particular, one of the last framework, it seems that you said it's not always the best path for your product to use machine learning models because there's a high cost of training the model. But at least what I read, and it would be curious to hear your perspective, is we're becoming also more efficient in training models. And I assume over time you will also start having a collection of working models, right? A model that understands language, a model that understands picture. So from your perspective, do you see future ML products be more like a combination of these Lego blocks of existing ML models, or will we always have to start from scratch in a sense?
So I think even today it's a combination, because a lot of times, as I said earlier, businesses want some hard constraints. So if you just use machine learning, it is not going to work. So it is today a combination of both. Sorry, what was the first part of your question?
It seems that a big cost is training the model, but I hear, like sparse machine learning models that don't need so much data. Like, do you see a trend of training models becoming cheaper?
So there is something called active learning, like which will use your the live feedback and then use that as a training data. So yes, like that is possible, but I think it really depends on your use case. If you can use active learning type of algorithms and it works for you, then yes.
Thanks.
Thank you very much. We're gonna cut it here. Please give a last applause for the questions and to Shambhavi.
Thank you. Thank you, guys.